In this video, I'm going to give you an overview of modern AI. We're going to go over the most important developments in AI so far to help you get caught up. So I created this interactive diagram here that you can move around and zoom. And it will help you visualize the most important developments in AI over the past few years and how they connect to each other. You can find a link to this diagram in the description. We're going to start in 2017 with the research paper, Attention is All You Need by Google. So this research paper is often considered the starting point of modern AI. Basically, what's inside this paper is it introduced a new design for an AI called the transformer. And this is what the original transformer design looked like. So the transformer can be used to create a specific type of AI called a language model. A language model is an AI that can understand and generate text. Now, the transformer had several advantages over previous AI designs. Number one, the transformer let the AI understand text more deeply by letting it look at the relationship of every word to every other word all at once. Whereas in previous designs, the AI would process the text step by step. The second advantage of the transformer is it made the AI training process more parallel, and this let us create bigger AI models. And it's these bigger AI models that made modern AI so smart and powerful. By the way, you can think of an AI model as a specific version of AI, like GPT-5. So basically, this research paper introduced the transformer, and this allowed us to create the big and powerful AI models that we have today. Following this research paper, in 2018, OpenAI created the language model GPT-1, which was one of the first AI models to use the transformer. Now, GPT-1 actually used a modified version of the transformer, which you can read about down here. GPT-1 was trained by giving it a large amount of text, around 7,000 books, and training it to predict the next word in a sequence of words. Now, to be more precise, the AI actually uses tokens instead of words. A token is basically a word or part of a word, and AI uses tokens because it's more efficient. So GPT-1 showed strong performance in many different language tasks, and it even beat previous AI models that were designed specifically for each task. So basically, GPT-1 proved that the transformer worked. Following GPT-1, in 2019, OpenAI created GPT-2. The purpose of GPT-2 was to take GPT-1 and test if scaling the AI or making the AI bigger improves performance. Now, one way we measure the size of an AI model is using the number of parameters the AI model has. A parameter is basically just a number that can be used to store the AI's knowledge or understanding of language. So more parameters generally means the AI can understand something more deeply. GPT-1 had 117 million parameters, while GPT-2 had 1.5 billion parameters, more than 10 times bigger than GPT-1. It was also trained on about 10 times more text than GPT-1. So GPT-2 had a big jump in performance over GPT-1. And it also started to show emergent abilities. An emergent ability is an ability that the AI gained on its own without being trained on it. For example, GPT-2 was just trained to predict the next token in a sequence of tokens. But once the AI model got bigger, it started to be able to do other tasks like summarize text or do basic translations. So GPT-2 proved that scaling works and it improves performance by a lot. Following GPT-2, OpenAI created GPT-3 in 2020. The purpose of GPT-3 was to test scaling as much as possible and see what happens. So GPT-2 had 1.5 billion parameters. GPT-3 had 175 billion parameters, over 100 times bigger. And now GPT-3 was known as a large language model, or LLM, because it was so large. And again, GPT-3 had a big jump in performance over GPT-2, and it gained much more emergent abilities. It could start writing short stories and poems, and even write code. So basically, GPT-3 showed that performance continued to improve with scale, and the AI gains even more emergent abilities. Now, one problem with GPT-3 was it wasn't very good at following instructions. It could generate really good text, but for example here, it doesn't understand that this is an instruction. It just creates some similar sentences. So in 2022, OpenAI created an upgraded version of GPT-3 called InstructGPT. InstructGPT used an additional training technique called RLHF, or reinforcement learning from human feedback. In RLHF, we basically give the AI an instruction and have it generate multiple responses, and the responses are ranked based on which ones follow the instruction the best. This information is then used to create another AI that can automatically score the responses, which basically automates the process. So this helps us guide the AI to respond in a certain way, like following instructions better. So InstructGPT showed that we can use RLHF to make the AI follow instructions better. So using these learnings, in November 30 of 2022, OpenAI released ChatGPT and GPT 3.5. So GPT 3.5 was an upgraded version of GPT-3, and it was trained with RLHF again. But instead of just training it to follow instructions, it was also trained to behave like a helpful assistant and to follow multiple instructions across a conversation, which made it much more useful. OpenAI also released ChatGPT, which is a chat web application around GPT 3.5. And it made it much easier for people to use GPT 3.5 by just chatting with it. So ChatGPT went absolutely viral. It was one of the fastest applications to hit 100 million users. And it proved that LLMs can be useful for the average person. Following the success of ChatGPT, in March of 2023, OpenAI released GPT-4. So note that ChatGPT, the chat web application, stayed the same. They just switched the AI model powering the web app from GPT 3.5 to GPT-4. GPT-4 had higher performance than GPT-3 overall, especially in standardized tests like SAT and the bar exam. It was also multimodal, which means it could understand different formats like text and images. However, GPT-4 started to show the limits of scaling. Simply making the AI model bigger didn't improve performance as much as before. So instead of focusing on just scaling, OpenAI shifted to adding features to make the AI more useful. They trained GPT-4 to use tools like web browsing and code interpreter, which lets it run Python code. So one of the problems with LLMs is that they tend to hallucinate, which means they make stuff up. So by using tools like web browsing and running code, it helps the AI verify its responses to make sure that they are correct. So GPT-4 was the first version of ChatGPT that could use tools. Now, around the time that GPT-4 was released, a bunch of competitors started to appear as companies started to see the value of ChatGPT. So the most notable competitors included Claude by Anthropic, Gemini by Google, originally released as Bard, Grok by Elon Musk's xAI, Copilot by Microsoft, Llama by Meta, and some Chinese companies also released notable competitors, like Ernie by Baidu and Qwen by Alibaba. Now, these were not at the same level as GPT-4 at the time, but they were trying to catch up. Now, to compare between AI models, we use something called benchmarks. So benchmarks are tests that measure the performance of an AI model, and it lets us compare AI models. So here are some popular benchmarks that you'll often see when companies release new models. MMLU, which tests broad knowledge. It contains around 15,000 multiple choice questions across many subjects. Another popular benchmark is called SWE Bench Verified, or Software Engineering Bench Verified. So this benchmark tests coding by letting the AI solve around 500 GitHub issues, and the code can be checked with unit tests. Another popular one is GPQA Diamond, which tests science with 198 multiple choice questions. AIM, which tests math with 30 questions where the answer is a number between 0 and 999. And HLE, or Humanity's Last Exam, which is often marketed as the hardest exam ever. And you'll notice that most benchmarks are actually multiple choice or short answer questions, instead of the long answers you normally get from an LLM. So benchmarks are a little bit different from normal real-world use. Another problem with benchmarks is that AI models can saturate benchmarks. This means their scores are becoming so high that it's hard to compare them. So in the future, these benchmarks may be different as we create newer and harder benchmarks to compare AI models. Now, on the other hand, we also have subjective benchmarks, which are benchmarks that are based on personal opinion, like LM Arena, where users get multiple responses from different LLMs, but they don't know which LLM it is. And then they pick the response that they think is the best. LM Arena also has a leaderboard that ranks the different AI models based on which ones users prefer. So going back to the list of different LLMs that we had, in addition to a chat application like ChatGPT, companies also released APIs for their LLMs. API, or Application Programming Interface, basically lets us interact with the AI directly using code, like this. And using APIs, companies can create LLM-powered apps. An LLM-powered app is an app that uses an LLM for their main features, like coding or web search. Some popular LLM-powered apps at the time were Perplexity, which is a search engine like Google, but it uses AI to generate the results. GitHub Copilot and Cursor, which use AI to help you write code. And Notebook LM, which lets you upload documents and discuss them with an AI. And using the APIs, companies could also create AI agents. An AI agent means the AI keeps taking actions until a task is complete. So normally, when you give the AI a task, it just generates an output. But with AI agents, we can give the AI a more complex task, and it will plan the next step. And then it will take action, it will get the results from that action, and then uses the result to plan the next step. And it keeps going like this in a loop until the task is done. So this loop is called the agentic loop. So some of the early AI agent tools were LangChain, Baby AGI, and AutoGPT. All of these used APIs to coordinate the AI and make it do this agentic loop. So zooming out, in 2023, we basically saw the maturing of LLMs like GPT-4 and the appearance of competitors, as well as using APIs to create LLM-powered apps and LLM-powered agents. Now let's move on to 2024. In March of 2024, Anthropic released Claude 3. Claude 3 was important because it was considered the first real competitor to GPT-4. So Claude 3 actually released as a family of models. So a family of models means multiple models with different sizes. So Claude 3 launched with 3 models. Claude 3 Haiku, which was the smallest and fastest model, Claude 3 Sonnet, the mid-range model, and Claude 3 Opus, the most powerful but most expensive model. And Claude 3 Opus was the first model to outperform GPT-4 across many benchmarks. Claude 3 was also really good at coding, and it became the default model for coding. One of the reasons it was really good is because it had a context window of 200,000 tokens, compared to GPT-4's context window of 32,000 tokens. So a context window means how many tokens the AI can remember. So with a much larger context window of 200,000, we could put a lot more of the code base into Claude, and Claude could keep track of much more code and had better reasoning abilities. So many developers actually switched to Claude as their model for coding. So basically, Claude 3 was the first real competitor to GPT-4. In May of 2024, OpenAI hits back and releases GPT-4o. O means Omni, and Omni means a mix. It means the model was trained on not just text, but a mix of text, audio, and images. As a result, GPT-4o could understand text, audio, and images natively. So natively means we can give audio directly to the model, and the model will output an audio response, instead of converting the audio to text in between. And this led to the introduction of advanced voice mode in ChatGPT, where we can talk to the AI model directly and it will respond directly with audio. So GPT-4o was the first Omni model that could understand text, audio, and images natively. Just a month later, Anthropic releases Claude 3.5 Sonnet, which is basically an optimized version of Claude 3. Even though Sonnet is supposed to be the mid-range model, it outperformed Claude 3 Opus, and it often had 2 times the speed at 1/5 the cost. So it was much more optimized than Claude 3. And this also solidified Claude as the default model for coding for at least the next year. So Claude 3.5 Sonnet put Anthropic back in the lead in coding and reasoning. A few months later, in September of 2024, OpenAI releases O1, which was the first reasoning model. So a reasoning model means the model thinks for some time before responding, which helps it give it more accurate answers. The model's thought process here is known as a chain of thought. So the model was trained using reinforcement learning by doing thousands of math and logic problems and being scored not only on the correct answer, but also on its thought process. And it became much better at solving problems overall. So O1 was the first reasoning model, where the AI would think for a bit before responding. And this put OpenAI back in the lead for reasoning, although Claude was still better for everyday coding. Next, in November of 2024, Anthropic introduced the Model Context Protocol, or MCP, which lets an AI model use external tools and services like GitHub or Google Drive more easily. So MCP is basically like a translation layer between the model and the external service. When the model wants to use a service, it basically translates it into an API request. Now, MCP contains 2 parts, the MCP client and the MCP server. The MCP client is usually created by the AI company. Its job is to use different external services and then give the results back to the model. And then the model decides what to do next. The MCP server is usually created by the external service, like GitHub. It takes requests from the MCP client and then converts them into normal API requests, for example. So using MCP, the model can just focus on reasoning and deciding when to use a service, rather than figuring out how to use a service. So basically, MCP allows AI to learn and use new tools easily, and this is useful for AI agents in the future. So in 2024, we had this back and forth competition between OpenAI and Anthropic, as well as the standardization of tool use with MCP. Now let's move on to 2025. In January 2025, a Chinese company called DeepSeek released DeepSeek R1. DeepSeek R1 was a reasoning model like O1, and it was notable for a few things. First, it was competitive with GPT and Claude in many benchmarks. And most importantly, it was an open weights model. Open weights means we can download the model and run it ourselves, which we can't do with GPT or Claude. It was also much cheaper to run, and it made the full chain of thought visible, which OpenAI at the time was trying to hide. So basically, DeepSeek was important because it was the first open weights model that was competitive with GPT-4o and Claude 3.5, and in many ways surpassed these models in terms of openness and cost to run. Then in February of 2025, Elon Musk's xAI released Grok 3. So Grok 3 was a version that made Grok competitive with GPT and Claude, beating them in many benchmarks, especially in math and science reasoning. It also had deeper access to X or Twitter data, giving it access to some of the most up-to-date information that you could find. So basically, Grok 3 finally made Grok competitive with GPT and Claude, and now it became a three-way race in the Western models. Then in March of 2025, Google joins the race with Gemini 2.5 Pro. This was also the version that made Google competitive with GPT, Claude, and Grok, beating them in many benchmarks. And it briefly became the preferred model for coding over Claude. So Gemini 2.5 Pro basically made Google competitive with GPT, Claude, and Grok, and now it became a four-way race. Then, in August of 2025, OpenAI released GPT-5. GPT-5 is known as a unified model. So before, we had this selector where we can choose between different thinking and non-thinking models. So these were combined into one model, GPT-5, that can now decide how much time to spend on a task. Otherwise, GPT-5 had modest performance improvements over the previous models. So GPT-5 was the first unified model from OpenAI. The next major development is the release of official AI agents. As a review, an AI agent means the AI keeps taking actions until a task is complete, using this agentic loop. Now, we already had AI agents back in 2023, but in late 2024 and in 2025, the big AI companies started releasing their own official AI agents, and 2025 is being called the Year of AI Agents. So in October of 2024, Anthropic released Claude Computer Use, which lets Claude use a virtual computer to help you do tasks. In January of 2025, OpenAI followed up with their competitor, Operator, which uses a virtual browser to do tasks. And this was later replaced by ChatGPT Agent Mode in July of 2025. And in May of 2025, Google announced their competitor, Gemini Agent Mode. So all of these are meant to help you do general tasks that require multiple steps. Now, in addition to these general agents, we also have more specific types of AI agent. So another type of AI agent are research agents. So these are AI agents that do internet searches for you. So they help you do internet searches, go through the results, and do more deeper searches if needed, and it helps you create a research report at the end. In December 2024, Google released their research agent, Deep Research, and this was followed by OpenAI with their version of Deep Research and Grok with Deep Search. Now, another popular type of AI agents is CLI agents. So these are AI agents that run in the command line, or CLI, and they control your computer using the command line. And these are especially useful for software engineering tasks. In February 2025, Anthropic released Claude Code, which uses the command line to complete coding tasks for you. And Claude Code has become one of the most popular AI tools for coding. And then in May 2025, OpenAI followed up with their competitor, Codex CLI. And in June 2025, Google released their competitor, Gemini CLI. And that brings us to today. In addition to LLM-powered apps and LLM-powered AI agents, we also have other AI tools that can help us generate images, video, and audio. You can check out some of these tools in this diagram. So some of these tools are built on transformers, while others use different kinds of AI models, which I'll talk about in a different video. So that is an overview of modern AI and the most important developments that you need to know. Remember, you can find a link to this diagram in the description, and I'll try to keep this diagram up to date as new developments happen. I also have an extended version of this video where I talk about which AI tools that I use in my daily life and in my work as a software engineer, as well as my reasons for choosing each tool and how I think about these AI tools. If you're interested, you can check out my membership in the description, which also has extra content like AI coding tutorials, as well as more personal videos from me. Thanks so much for watching this video. I hope that it was helpful to get an overview of the major AI developments and the major AI tools. If you have any questions or topics that you want me to cover, please leave them in the comments, and I'll see you in the next video.